Hi, everyone. I'm going to be presenting in English today. I hope it's going to be okay. So, my name is Josip, and I want to talk today about this new library framework, whatever you call it, which I found out about recently, and I thought it was very interesting, and sort of took some time to sort of check it out, and I would like to tell you about my findings. So just a little bit of info about me. So I work in this tiny company called Celerent, and we do enterprise Java development, basically. We're very small, but we do cool projects and interesting ones, and ones which impact all the people. So if you find anything interesting here, please talk to us. We're looking forward to hear from you. So, containers, right? These things are what basically drives a lot of changes in the application development space in the last years. And the reasons are known very well. It's mostly due to basically optimizing the user hardware resources for application workloads for various scenarios where we deploy large composite applications, especially ones based on, say, microservices. So, as I normally work with Java, I'm mostly interested in Java and containers, right? And the thing with Java and containers is that it wasn't really working very well up until a few years ago. So with Java 8, you had pretty big issues. And they all basically boil down to one problem. So JVM thinks it owns the machine. So if the machine is a 64-core, 1 terabyte RAM server, our JVM will try to grab half the RAM and grab a huge number of, or say run a huge number of threads and so on, because it doesn't recognize it runs within the container. What happened with Java 8 applications, they tended to crash the JVM. Now with Java 9 and 10, some improvements were made, and now Java does sort of recognize that it runs within the container. It does respect C groups limits like CPU limits, RAM limits, and so on. But still, it's less than ideal, right? JVM tends to have a large RAM usage because of its just-in-time compiler, metadata classes, and so on that are needed alongside with the application heap. And there's the problem of the startup time, warm-up time, and so on. And now, if we go one step further and want to do serverless, we want to do lambdas. Well, the thing with lambdas is they spin up when we need them, right? So I hope we'll be all familiar with what lambdas are, right? Lambdas are the, let's say, they enable us to run applications without caring too much about the server infrastructure, right? The service provider gives us, let's say, allows us to deploy some application and we run it, but they spin it up on demand, right? And if you use Spring Boot, for example, it will take us like 5 to 10 seconds, depending on the complexity of our application, to start up. If our first user hits the app, you know, he can only twiddle his thumbs, right? If the next, let's say, instance is started up on a high demand, the user that arrives on the next instance will also wait for 5 to 10 seconds. This is something that really might be an issue for many applications. Also, Amazon charges us by CPU time, and they charge per 100 milliseconds. So 10 seconds is a lot of, you know, little charges. So this is Delphi in Greece, and there used to be an Oracle there. So Oracle is coming here to help us a little bit with its new GraalVM. Has anyone here heard about GraalVM, please? Okay, did you have an opportunity to play with it a little bit? Okay, so it's a pretty cool thing. So it's basically a new cross-language virtual machine, but it's much more. So it intends to support lots of languages, aside from Java and JVM-based classical languages like Scala and Kotlin and so on. So we will be able to actually run JavaScript, Python, and so on, while interoperating with Java. This could be very cool for some situations where you have some legacy libraries and so on. But the thing that's more interesting for us today is the fact that it can build native images. So if you remember, Java is an environment where the final compilation or the optimization of our bytecode is done in runtime, so basically just in time. And while that enables some cool things, it's slow. It mostly takes a little bit of time for the VM to warm up and to start running quickly. Native images allow us to build self-contained small little applications that run instantly. GraalVM native image does lots of static analysis and enables us to initialize, the application is basically initialized or built or pre-configured at compile time, and this is what enables the quick startup. And what are we talking about here? We're talking about almost 100 to 1,000 time order faster startup, and in some situations up to 10 times of less RAM usage, because we don't have to run the whole JVM. We have only our code running in the native image, right? One thing to note about GraalVM, it's an open source product which has an enterprise version. So some features, also some things we're going to talk about today, do depend on the enterprise version, which is of course licensed separately and charged and so on. But most of what we do today, we are going to do with the community edition, and it is open source and free to install. So let's just have a very, very quick, simplest possible try with GraalVM. Have literally the most basic hello world program here. So what do we do with it? We compile it with Java. And now we can run it. Say we run it like this. We can also time how long it takes, right? Now, we can also build a native image. This native image is a tool which comes with GraalVM. We simply give it a compiled class name. And it's going to take a little while, because what it does, it does a thorough static analysis and sort of code reachability analysis and so on, and it only collects the code that will definitely be run in the runtime. So it eliminates all the extra stuff. So our executable will be minimal. And in this case, it's built this hello world executable. It's just 2 megs. We can copy this hello world to another machine and run it. It doesn't need the JVM, and it works. And also, if we time it, it works quite a bit faster, right? So in this case, it's the most simple possible example, and it's, let's say, 10 to 20 times faster, right? Okay, so returning to the presentation. Well, I wish it was this simple. So we just take our applications, we compile them natively, we deploy them, and we're done. However, there are some limitations, because we don't have the JVM in the runtime. We basically cannot do any dynamic code compilation in runtime. And lots of complex frameworks, they rely on dynamic class loading. They rely on runtime bytecode generation, cglib, stuff like that. This includes Hibernate. This includes lots of large parts of the Spring framework and so on. So it's a bit tricky, right? But there is some limited support within the GraalVM native image builder, but it must be configured manually. So we must declare all the classes that may be initialized at runtime. We need to sort of guide the compiler to know what to do with our complex frameworks. So this is the complexity that comes with the native image builder. And some libraries will never work because they depend on runtime dynamic class generation and loading. So to help with this, some nice people from the internet, they built some cool new frameworks, right? And these frameworks, they take out all of the complexity from building these GraalVM native images, and let us, just work as normal developers. Enjoy writing some simple, useful code. Quarkus is the one we're talking about today. There's also Micronaut, there's Helidon. There's been some info that Pivotal is working on having Spring also work with this, but it's a work in progress. And of course, many more are coming. So let's focus on Quarkus a little bit. So it was announced a little bit more than half a year ago. So it's really, fresh, new, and the development is very intensive. It's still 0-point-something versions, 0.22, 23. So if you look at semantic versioning, this means it's not really fully production ready, but it's being developed very quickly. New releases are coming out weekly. What does it want to do? It wants to help us make it easy to build microservices targeted for the GraalVM native image. It's based on on the micro profile. Has anyone here heard about the Eclipse micro profile? So micro profile is a sort of a new, relatively new set of APIs or frameworks or standards that aim to replace the classical enterprise Java, right? Java EE, to better support microservice frameworks. This means we use standard JSR APIs like Java Persistence API, the JUX RS, the context dependency injection, so on. So we are using sort of traditional JEE-based APIs, but with additional stuff that helps us run simple, easy microservices. And it's easy to target container environments, right? It's easy to build a Docker image for the natively compiled application and deploy it to Kubernetes. There's some support for reactive applications and so on. And the effort is Red Hat led, right? So this is just a little screenshot from their website to see the libraries they support. They decided on picking certain libraries that they will sort of prepare for us to be able to build native images for them. So what they do, they basically create a framework which enables them to create extensions. And extensions do all the fine-tuning of the GraalVM to enable the use of all these libraries. So the Vertex allows us to do web applications which are reactive. This is very, very cool because they scale very well on single machines. So we use Hibernate. We all know Hibernate, and that's a good thing that we can use it, even though they managed to make it work, even though it relies on some dynamic bytecode generation, right? And so on. So there's the microprofile, there's the Kafka, and so on. It depends on what you use, what you need. This is also a screenshot from the website. and these are the savings that they claim, right? So you can see in terms of memory usage, for the simplest REST application, which doesn't access the database, we have 1 order of magnitude less RAM. So it's 13 megs of RAM for it to run. For JPA REST service, which accesses the database, also huge savings in terms of the resident memory. But much more impressive is the startup time. And we are talking about milliseconds instead of seconds, right? Up to 10 seconds for a, let's say, more complex application compared to 55 milliseconds, right? So let's say we wanted to build something with it. We want to construct an application. How do we start? The kind folks at Red Hat have created a nice little website. If you used Spring, there's a Spring initializer. It's a similar concept. So this one will allow you to, enter your application's name and select a few libraries that you want to use, and it will build a starter application for you, and you can work from there. So that's quick and simple. But for this demo, I will not use it. For a simple reason, it relies on Maven, and I like Gradle, right? So I made a demo which is Gradle-based. It takes a little bit more work because currently their website doesn't create Gradle scripts. So this is the simplest possible. Let me just, sorry. Okay, this is the simplest possible, basically hello world REST service, right? We have one endpoint, and it returns a JSON object containing the single hello world message. So if we build it as a Java, I've already done the building here, so it's already ready. We can run it as a Java application. Okay, it took a little bit more than a second to run. You can test it. Okay, seems to work. We can check how much RAM it uses right now. So I'll do some okay, so it's 343 megabytes of RAM just to run this simple Hello World REST demo. Now, if I start the native compiled version, it's a little bit different. So now it's much quicker to start. Works the same. And the RAM usage is 15 megabytes. So that's pretty cool. If you remember, you have a RAM-constrained server, this will help you a lot. So this is a simplistic example. And it's based on the Chux RS API. Now, what if we like to use Spring? So the Spring framework. While Spring is working on supporting GraalVM separately, the Quarkus people have actually implemented a compatibility layer, an API level compatibility layer, which will allow us to run some, let's say, to create some REST services, to use Spring Data JPA, to use the tools that maybe we already know how to work with. There are some limitations, but in some simple cases, it will allow you to start quickly if you know Spring better, and it will maybe allow you to migrate some applications, some legacy applications. Now, I have actually made a little bit more complex sample for this. So as you see, we have Spring. Sorry, I need to exit the. Okay. Let me just. Okay, this is not the. Okay, yeah. So we're seeing here Spring Framework classes, and we built a very simple controller which uses some repository based on Spring Data JPA to fetch something from the database. And of course, if we try to run it, it should work, right? Okay, I haven't killed the previous one, sorry. Yeah. Okay, it returns something. It's not very pretty to look at. Here's a pre-printed version. Okay, we get some countries. Also, the difference, I mean, in this case, we are accessing the database, and it takes a little bit longer for it to start up, 2 seconds. And I will not test the heap now, but it's the same order of magnitude. Now, running the Quarkus version, also much quicker, works the same, right? The thing I did here now is a little bit more advanced. So I've actually connected to the Oracle database here. And Oracle driver is not officially supported by Quarkus right now. So I've had to basically, let me just find, I had to do some customization. I had to add some additional properties and settings that will drive initialization of very specific classes within the Oracle driver to make it even compile. So that's the thing that Quarkus saves us from. So in this case, I wanted to do something that Quarkus doesn't support. And I had to run the application in test mode many, many times, rather run the native build, and to see it spew out some errors, and to have it guide the native image compiler with very specific flags. So it took a while, and this is a bit of a minus point for this approach. Okay. So how much time do I have left? Like 5 minutes. Okay, great. Now, what about actual runtime performance in this scenario? So what we are doing here basically is comparing JVM-based Java runtimes with those built with a native image. Now, if we are talking about the performance, we need to be precise. What are we talking about exactly? So are we talking about throughput, means the number of requests a certain machine can process per second, or the start time, or the resource usage? Well, the optimum may depend on the specific measurement that we are making. And the reason is that just-in-time compilation uses information collected in runtime to optimize our code. And due to some properties of modern processors, speculative execution, branch prediction, and so on, this upfront profiling can really make a huge difference in terms of performance. And the ahead-of-time compilation can't really always make use of this. So we won't easily see the same result in terms of performance of throughput with the native image that we see with the good old JVM. And I've built a little bit more complex demo for this too. So we have the same simple hello world services in the first example, but we're doing some a little bit more heavy calculation here. We're calculating some hash 10,000 times just to make the CPU work a bit so we can actually measure something. And what I did is I built a little let me just run the Java version because we don't have much time. Okay, so I don't have it built. Okay, let me just, okay. I'll build the Java version quickly. And we will look at it a little bit, and I will build the native version while we are checking something else out here. Okay, and I will run this little app. So what I did here, so now the native compilation is taking a lot of my CPU, and this is going to be a little slow until it finishes, but what I did is I prepared a JMeter script here. So this is a load testing tool. And I want to measure the actual runtime performance of these two use cases. So I wanted to compare the JVM to the native image. And this is really trivial. I just basically bang on the endpoint repeatedly for 100 times. And I just use one thread. I don't really overload the machine. I just want to test basically the CPU performance. And because our calculation now is heavy, and it does a lot of computation, we should see an effect of optimization, right? So the thing is, with the native image builder, it takes a while. So it might take like a minute and a half to build something in this case. So I'll just have to wait 10 seconds more. What it should do is let us make a direct comparison. Okay, so we are running the Java version now, the JVM, sorry, version now. And please make note of this here throughput field. So the thing is, we run it, runs 100 times. There's a 100, let's say, 100 requests per second in this case. I do it again. Oh, sorry, I needed to reset. I do it again. I have 200. Why do I have 200? Because in the meantime, the JIT has done some optimizations, and it made my code faster. So it made it run faster. Now, if I run it the third time, it's even faster, right? 225. It did more optimizations, and so on. So the longer my application runs, the faster it runs. And this is the way it works with the JVM. Now, if we switch to the native build version, first of all, it starts in 14 milliseconds, which is quite impressive, right? Still. But now we test for the throughput. 80, right? Okay, maybe you did some startup initialization as well, because we're doing the hash calculation, and there's some maybe algorithm initialization. So let's try again. So it's 90, right? We had 100, 200 with the JVM. We run it again. It's still 90. It's always 90, right? It doesn't improve because it's precompiled the way it is, right? Okay. So that's a little bit of a trade-off. Now, is it possible to get best of the both worlds? There is a feature called the profile-guided optimization. And what it does is it enables us to basically record and profile our application during some test runs and some load runs, performance test runs. And it records the profiling information that JVM would normally collect. And then we can use it to build a more optimized native image. And this is basically as easy as it's shown here. So it's two commands. It's one to run the application in profiling mode, and it's another to use the profiling information to build our app. And that's basically it. So I don't have time to demonstrate it, but one important thing to note here, it's an enterprise-only feature. So there are some things that Oracle saves for their paying customers, as expected. Right? Okay, so to wrap things up, Should we use something like this? Well, talking about Quarkus itself, there's no reason not to use it immediately. So it's if we use it in JVM mode, so we basically run it as a Java application, it's rock solid. It has mature libraries, and it still performs the best in some workloads, in some scenarios. However, the main selling point of Quarkus is that it enables easy native image building. And this can be very beneficial in many use cases. It can reduce hosting costs. We need less servers. It can enable us to deploy applications in new environments like mobile devices or desktops, and so on. But it's still kind of experimental. And the big showstopper for many enterprise deployments is that it lacks official support for database drivers, for Oracle and DB2, let's say. And the MS SQL support is kind of limited, but okay, they're starting to support. So this will change over time. And they are working on supporting as many use cases as possible. But now at this point, it's still a bit flaky. Also, if you have any legacy libraries, it may depend on some unsupported Java feature. They might not work. So there's things to watch, to take care about. And let's say my final verdict or opinion would be follow this technology. It will develop quickly. It will grow quickly. Try it out. Check it out. See if it works on your use case. But if you do decide to use it, test thoroughly. There might be some execution path somewhere in your legacy library that will cause the application to crash, and you won't be able to go around it. So, and be ready to fall back into JVM mode. Don't order 10 times less server capacity for your application before this runs well. Okay, that's basically it. Okay, thank you for the presentation. I'm ready to take any questions.
We have a first question.
Yeah, why would I pick Quarkus over Micronaut?
Basically, it's I think it's a matter of maybe a preference of the frameworks that you use, or the trust you have with the vendor, right? So this is something that's developed by Red Hat, by serious enterprise company owned by IBM today, right? So that's one argument. Another argument is the libraries that they support, or the, let's say, the effort they put into making it work smoothly. But basically, it's a matter of choice, because Micronaut also supports the same style. You can use JAX or REST.
Even better, actually. But
yeah. Okay, I didn't actually evaluate Micronaut as much, so I cannot really say from my experience. But I would say it's a competitor.